Hello and welcome everyone. Good evening if you're in the Netherlands or in Europe, and good morning or good evening wherever you're watching from. And that's the beauty of online. Anyone can join from anywhere. I'm hosting this from the Netherlands, and we have a Dutch guest as well, Henry, who's somewhere on the other side in the Netherlands on an island. So he's probably really enjoying the isolations. Not that much changed for him, I guess. But really glad he's on this call to learn about telemetry, logging, observability, monitoring of your code on Azure. So thanks for being here, Henry. Yeah, please introduce yourself.
Well, hello, everyone. Good evening. It's glad to be here. Thank you for the invitation. It's, I think, the second time that I'm doing this instead of for a live audience through a video call like this. And I always struggle, so I hope you bear with me. I will be talking to you for roughly an hour or so about logging, instrumentation, dashboards, and alerts. And I will take the angle of the developer, and more specifically my own angle. It will be about the things that I have learned over the last couple of years with regards to these topics. So to quickly start with who I am, my name is Henry Been. I am
now I enabled your slide, so from now on you can display whatever you want.
Ah, awesome, thank you. So my name is Henry Been. I am a developer and architect from the Netherlands. My email address, Twitter and LinkedIn handle are on the screen. If you have any questions or whatsoever, feel free to reach out to me afterwards, because I'm not taking any questions during this presentation. But feel free to reach out afterwards. As Geert mentioned, I do live on a small island off the coast of the Netherlands, which is called Texel. So, well, it's not like that I'm really used to living in isolation, but yes, it's rather small here, and I am thoroughly enjoying the countryside these last couple of weeks. And that's, by the way, I really hope that all of you are healthy and safe as well. Did you want to interject, Geert?
No, I did not.
Oh, sorry. Cool. Okay, so what I want to talk about is logging, instrumentation, dashboards, and alerts. And for me, I've given very, very deep thought about how to structure this talk. And so I've done this all throughout Europe, where people are very critical. So I came up with these contents. First, a very boring part, then a pretty boring part, and then a maybe boring part. And hopefully, maybe someday, or even today, I'm reaching people in America, and I also made, a slide of contents for them. First, it's going to be amazing, then it's going to be really amazing, and then it's going to be mind-blowing, or at least that's what I hope. But I'm Dutch, and my wife as well, so she pointed out to me that it doesn't really tell you anything about what we're going to do. So this is what we're really going to do. I'm going to teach you a little bit about monitoring theory, and then especially what I have learned. And then we're going to talk about what to monitor, and maybe what not to monitor. And then I will do a number of demos on how to do that on Azure using application insights. And the essence, I think, of all the things that I'm going to show is the following, that monitoring is about knowing what is happening in your production environment without logging into that environment yourself. Knowing enough about that environment to know if your users are happy, if you are getting revenue, if everything is working as expected and as it should be. And to do that, we can do three things regarding monitoring, sometimes called the three pillars of monitoring. And the first one is instrumentation. It is the art of getting numbers out of your application. And of the three that I'm going to talk about, it's actually the one that's most often forgotten, I think. This concerns us with metrics, like I said, the art of getting numbers out of our application. Things like the number of requests per second. But maybe also the number of unique visitors per minute, the number of euros spent on my website per minute, these kind of numbers. And all the things that I talked about right now, they're values. We can also differentiate towards another kind of thing, which is an event. For example, somebody adds an item to a basket. Somebody logs in. So these are things that I want to record, and not necessarily the value, but how often they occur. One of the things that also is interesting about metrics is that we can add dimensions to it. So let's say I have a metric called the temperature, for example, in this room. It's roughly 20 degrees right now. Now I can create a metric called a temperature in the room of Henry, and I can create a metric called temperature in kitchen and temperature in the living room. But that makes it rather hard to, for example, compare these values. So instead of that, what I can do is I can define one metric called temperature, and then I can record 3 values in combination with the, for example, location of that temperature. So then the metric is temperature, the dimension is location, and instead of just a date time and a value, I'm going to record a date time, a value, and a value for the dimension. So 8 o'clock, Henry's room, 20 degrees, 8 o'clock, kitchen, 90 degrees, etc. And we will see how that works later on in more detail. Now, of course, metrics, if you graph them, you will get a line. And if you combine multiple lines, you get a dashboard. So metrics are the basis for dashboards. And if you also graph a second horizontal line on a dashboard or on a graph, and you detect it whenever a graph goes below or above, and then you get a signal, then we also have an alert. What is good to know about metrics is that they're often rolled up over time. So let's say I'm collecting a thing like, I don't know, the amount of memory in use. Maybe I want to collect that every second so that I have very detailed information about what's happening on my system. But on the other hand, that's going to generate a lot of data, and I got to store that and I got to query that, and that's very expensive. And the value of that very precise information decreases over time. So instead of storing that information maybe for years, we're going to make that information a little bit vaguer over time. So for example, for all the information that's more than a week old, we're not going to record the value anymore every second, but we're going to throw out 59 values out of every 60 so that we have one measurement per minute. And of course, we can take the average of the 60 instead of just throwing 59 out. And this is what we call rolling up the data. A second thing is tracing. And I think this is what we developers call logging. This is concerned with emitting very detailed information from our application about what it is doing. It is very code-centric. It is very concerned with the application code that we have written. It often contains a date and a time, the location in the code, the file, the class, the line number even, and then some string that we want to emit, and maybe the value of a number of parameters. This generates huge amounts of data, and often we retain that information for a rather limited amount of time, maybe even just 2 weeks or 4 weeks, just long enough to use it for troubleshooting. That's the main thing that we use tracing data for often. And of course, tracing can also be a source of metrics because the number of log entries emitted is also a number that we can gather, and the number of error level messages can be interesting as well. The third thing is what the literature calls logging, and what we often call audit logging. And it's roughly comparable to tracing because it does the same thing. You emit messages from your code, but instead of being very code-centric, you are now much more business-centric. You are recording interesting state changes in the system that are important for your business. For example, Henry ordered a pizza. Henry paid a pizza. A pizza was delivered to Henry at that time. This is where you go if somebody claims that something didn't happen. This is your proof of record, your record of proof. This is also where you go when you find out that my account has been compromised and you want to see who has been ordering pizzas in my name. And maybe it's the place where you go to find out why I ordered 175 pizzas. Now, if you want to use this information for all these means, you're probably going to detain it longer than just 2 or 4 weeks. So instead of tracing information, you're going to retain this often for indefinitely if you're smart. Now, how do we gather all this information in our application and store it somewhere so that we can later on query it and visualize it and alert upon it? Well, almost all the architectures that we see nowadays take more or less the same form or shape. And it looks something like this. We have an application instance. This is our code. And our code is almost always running on something. It can be a virtual machine. It can be a container. It can even be our application can be a function that is running on an Azure function plan. But no matter what it is running on something. Now what we can do is on that something, we can install an agent, an extra piece of software that is going to collect a lot of information about that virtual machine or container and the complete stack below it, the network, the memory, the CPU, all those kind of things. And next to that agent, inside our own application code, we are going to install an SDK. Now both that SDK is going to gather metrics that we in our application code generate. So they are application specific. And the same holds for logging. That agent that can log information about the system you're running on, and you can use the SDK to emit log entries that you're interested in yourself. Now, since more and more of these application hosts are becoming very volatile. They can come up, they host their application for a few minutes, and then they go down again. So we cannot really keep our logging and metrics on that application host. We have to send it somewhere else. And we're using HTTPS for everything nowadays, so also for submitting logs and metrics. And from there on, all the logging is often kept in a thing that is very similar to a database that you probably know, a relational database. And it's a thing that you can query more or less in a way that you're familiar with. Now, of course, this database is optimized for scenarios like append only and free text querying, and not necessarily for, I don't know, getting the average out of a couple hundred lines that a normal relational database is. Next to that, we have a time series database where all the metrics are stored. And these are databases that are optimized for storing ranges of date, time, and value tuples, lines in graphs. And we can query those databases as well, but instead of looking at the table that they give us back, we often want to plot the results. So we often query them through a visualization engine, and the query results are our dashboards. This is all about retaining information for looking at it later on when we have a question. If somebody calls and says, hey, I didn't get my pizza, what happened? I go to my logging database and I try to find it out. And if my manager or somebody else in a suit wants to get a graph of the number of pizzas that are being delivered by us every day, I create a dashboard for him, and he or she goes looking at a dashboard whenever he or she wants that information. But that's not always useful. Sometimes I want to get notified whenever something happens. For example, when the number of logs drops to 0, I might want to get notified. So for that, we take a different approach than storing everything in a database and querying that. In that case, we're taking a streaming data approach. So all the data that comes in, either logs or metrics, goes through a streaming data engine. And instead of storing the data, that engine stores the queries. And for every record that comes in, the engine determines which queries need it, send it to that query, and then drops it on the ground. It's not stored or anything. And every query, whenever a new result or a record that's interesting for a result comes in, it takes that record, it answers its query or calculates an intermediate result, and then throws the record away again. So it's the other way around. It doesn't store the data, it stores the queries. And those queries are probably going to be conditions that we want to get notified about. So they are our alerts. And we can do that for both time series, but also for things that are in our that are coming in through logs. Now, remember that I promised that we first do a lot of boring stuff like slides. So I changed my mind yesterday, and I thought, let's dive into Visual Studio and give a number of things a try, unless there are any questions already at this point.
I don't see any questions yet, so let's just continue with the awesome part.
The awesome part. So what I've done, and that's very, very awesome, I hope, is I've done a file, new project, and then I created an ASP.NET Core 3.1 getting started project, which, by the way, is new for me. It doesn't generate a values API anymore. It generates a weather forecast API. It's really cool. So let's spin it up and see what it does. And what I've done after I've created this project, I have copied in a gitignore file, done a git init, and committed all the files that were already there, so that we now have a repo where we can monitor anything that I change. And this is what the API does. It basically gives me a little bit of JSON that I might be interested in, or not really. So let's kill it. Now let's assume that I want to add some logging and metrics gathering to this solution, because it is pretty awesome. So what I can do is I can start using a service in Azure that is called Application Insights. And we will explore it in more detail later on, but just think about Application Insights as that big fat database that's going to contain all our logs and all our metrics. So what I'm doing here on the top right, I am finding connected services in my solution. And I'm going to click it, select Add Connected Service, and then I'm going to say I want to do monitoring with Application Insights. So let's click that. And what it now does, it sees if I'm connected to Azure, and I am. I'm logged in actually. And it's, well, this fancy marketing slide, this will allow me to detect and monitor everything that's going on in my solution. Awesome, let's get started. Now I have to re-log in every now and then, actually every hour nowadays. It's probably got something to do with two-factor authentication. So here we are. I'm now logged into Azure once again. This allows me to register. What this does, it generates an Application Insights workspace in the background. It's just a resource in Azure that we will see in a little bit of detail later on, but it's generating one for me on the fly right now. Another thing that it does, it is going to add the Application Insights SDK to my project. It's just a NuGet package that's getting referenced. The third thing that it does, it is going to that Application Insights workspace and it's getting out a thing called the instrumentation key. Think of it as an API key. And it's putting that API key in the configuration of my application. And now we see why I did this git thingy. This allows us to inspect the files that I've changed. So the connected service.json is just a little bit of bookkeeping for Visual Studio. Then I can go to my profile. And what I see here is that a NuGet package has been installed. It's called Microsoft.ApplicationInsights.ASP.NET Core. This is the SDK that we need to do both monitoring and logging. The second thing it did, it picked up this instrumentation key from Application Insights and put it in my settings. So now what is running on my local machine is connected to the workspace within Azure. And the final thing it did, as a lot of SDKs do nowadays, in my configure services for my application, it added a call to add Application Insights telemetry. And this registers all the instances and all the interfaces that are needed for monitoring and logging. Now, instead of doing this add connected service, you can of course install the SDK yourself and add the instrumentation key manually. This is especially handy if you want to roll out your Application Insights in a more structured manner than just having it generated by Visual Studio. Now, if I now go to the controller here, as part of this project, you can see that one thing that's already being done is that an iLogger of T, an iLogger of weather forecast controller, is injected in the controller. Now, this iLogger interface is part of ASP.NET Core, but the implementation of that interface is not. And depending on which framework you are using for logging, be it Serilog, Nlog, Application Insights, I don't know what, they can all hook up to this logger to start getting your log entries. So this is a generic interface that you can always consume, no matter what library you are using for emitting the logs. So one of the things that I can now do is underscore logger and say logger warning. Oh no, someone is trusting the weather forecast. Like I said, I live on an island, and one of the things that you learn to do is to never trust the weather forecast. Now, if I run this application again, I get a result. Beautiful. But if I now minimize this, you might see that in my toolbar, I've got a new entry, which is called Application Insights. Now, if I click that, I get an interface where I can search all the things that are being emitted by my application. And there is just one thing right here. And this is not actually not the log entry that I emitted. This is a request that's being recorded. So ASP.NET, it wingles itself into the ASP.NET core runtime to detect all the requests that come in. And it generates a log entry in a request table out of it. Well, it's not an air quotes table, it's an actual table. You'll see later on. Now, one of the other things that I can do is I can see which kind of things that I'm interested in for application insights. So we've seen one request. Let's now also look at a thing called traces. And this are actually my application logging logs I emit. So what we can see here now is that a new entry has been emitted. Oh no, somebody's trusting the weather forecast. This is how I configure logging for my application. And this is also how I start emitting log entries. Now, I can access this from Visual Studio because I'm debugging this locally. But what if your application is running in the cloud? Well, let's have a peek what has happened in my Azure subscription meanwhile. So I'm now going to the portal. I go to Application Insights Workspaces. And you can see that a new Application Insights instance was generated. It's called My Monitoring Demo. It's in an awfully named resource group in EastUS. Doesn't really matter for now. This is why you shouldn't create things from Visual Studio. Now I open this instance of Application Insights, and one of the things that you see here is the instrumentation key. This is the same key as we can find also in my application settings. 64C66. One of the things you might notice is that it's not really being treated as a secret. It's plain and visible, but I would highly recommend you to treat it as a secret as much as possible. Now, all the log entries and metrics that we will see later on come into Application Insights. And let's first explore a thing called live metrics. This is actually quite fancy because what it allows us to do, it's going to connect from the portal to my Insights workspace. And it will give me a real-time view of all the things that are being collected by Application Insights. So if I now go back to my demo, I press F5, I go down, I can see that the request rate has spiked to 1 request per second, down again. I can see the request duration and all kinds of other things like the CPU usage, whatever. So if I go in there again, press F5 for a number of times, we'll see more data points coming in right about now. Another thing that you might notice is that on the right, all the traces that I emit are coming in live as well. This is how easy it is to get started with Application Insights. Let's take a quick look at a number of things that we can tweak. For example, if I go into my Application Insights of app settings configuration, one of the things that you can also see, let's make this a little bit larger, is that a section called logging has been added to my configuration. And within that section, another section called the log level. Here I can decide which logs I want to send to Application Insights and which not. So the default for all the things is everything above information. But you can imagine that I am running a lot of ASP.NET Core from which I do not want all the information on logging. So what I can also do, I can specify for namespaces, or actually the most significant part of namespaces, an override for the log level. So for all the classes which fully qualified name starts with Microsoft, I only want to get warnings. And for everything that starts with Microsoft.hosting.lifetime, I again want to see information. So I can override this and I can say things like stop debugging, go to the weather forecast, pick up my own namespace, go back to the configuration and say, well, for this namespace, I want to see debugging up. And this way I can decide on how much information I want to receive from which parts of my application. Now, there is more that we can get out of Application Insights, actually. One of the things that I can also do is I can go back to my controller class and I can make a very interesting call like this. I don't know, for new HTTP client. By the way, never new an HTTP client. Dot get async HTTPS. Always use HTTPS. nos.nl, which is a famous website in the Netherlands, which has the brightest of journalists asking the smartest of questions after press conferences. So what I'm doing here right now is I'm calling into a REST API or another service. If I now run this application again, and I wait for the forecast to show, a couple of times, minimize again and go to my application insights. I can now, except for just traces, I can also enable the filter for dependencies. And if I now update, I can see that application insights has detected that I am calling another service. It's doing a get from here. And unfortunately, we do not see the URL right here. But if I click the details for it, you can see that this is for nos.nl. Now, this dependency detection mechanism is actually quite smart. If you're, for example, calling a SQL database, it will detect that you're running SQL queries. If you are calling into a Cosmos DB, it will detect that you're doing document queries. If you are sending something to a service bus or getting something from a service bus, it is detecting that as well. So it can detect a fair number of dependencies. Now, I hope you trust me when I say that a more or less similar thing is available for exceptions. Every exception that gets thrown, not just unhandled exceptions, every exception is recorded in a similar manner. Now, there is one more thing that I do want to show, and that is that I also can work with metrics out of my application. So let's add another class dependency. I'm going to do a telemetry client, and this is a class that is built into application insights. I save it into _telemetry client. I use a quick refactor to get it through the constructor and save the reference. So the dependency registration for this class is done with that call to add application insights in my configure services. So now I have a reference to my telemetry client. I can do things like this. _telemetry client, and I'm going to get a metric, and I'm call that metric, I don't know, weather forecast received, and I am going to track a value of 1. And let's stop debugging for a bit to remove all the squirrelies. See if the thing compiles. It does. Hit F5 again and start up our application again. Takes a few seconds. Hit refresh a number of times. And now comes the really annoying part. We have to wait a few seconds. Because whenever a metric is calculated or recorded using track metric, it is not submitted directly. Actually, it is buffered in the application insights runtime for a while, and an aggregated record is calculated, I think, every minute, and then submitted to the application insights workspace. This is done to reduce the overhead, because you know the number 1 is very small, so there is a lot of overhead compared to those values. So I hope if I now select all and hit update, we will see that a metric has been recorded as well. Not yet. Let's refresh. Trace request, dependency. It's not fair. Let's do it a couple more times. See that the live metrics are still following us along in the background. And update. Here we go. We now see that a number of metrics have been recorded and have been submitted as well. And if I now open them one by one, let's see if, there we go, weather forecast received. And as you can see, it's not submitting the value of 1 13 times. It is submitting the value of 13. And it's saying that this is an aggregation, a pre-aggregation for this metric. I thought this would be enough of screw the slides. So let's do a little bit more slides, but I hope you now have a bit of a feel for how easy it is to take any application, doesn't necessarily have to be a web application, connect it to an application Insights workspace and start emitting data. And at this point, you might be thinking, Henry, all the things that you show me, I consider operation stuff, not developer stuff. Why would I even care about it? And I will admit that has been my stance regarding these kinds of things for a couple of years at the start of my career as well. Well, I think every developer should care about this. Not necessarily because DevOps is cool or we want to have DevOps powers, but because I think there is real value in DevOps. You know, working together between developers and operators to very quickly and fast and often deliver value to our end users. And to do that together, you have to communicate. And to communicate, it really helps if you know at least a little bit about what the other person is doing to have a very good conversation. And another reason is, if you as a developer do not start emitting these things from your code, an operator cannot work with it later on. So I think developers should learn about this stuff. I hope I have persuaded you and that you're now moving on to the next question. Cool. But what to monitor? And I thought let's take that question, flip it around and have a little bit of a conversation about what not to monitor, because that can be so much more fun. So the first thing that a lot of people start doing when they first get into contact with monitoring is that they start focusing on their systems. You know, the operator comes by or the developer and he yanks a system into monitoring. It kind of means I'm going to do CPU usage, memory usage, page file usage, number of IOs, and disk space still free. Awesome. What does that really tell you about how your users are using your system, or whether your users are happily using your system? Nothing really. So I would advise against overly focusing on your systems. Another thing is averages. Averages are lying, cheating bastards that hide real problems. I think a lot of APIs in the world have an average response time of somewhere between 20 and 120 milliseconds. And a fair share of them roughly hover around 100 milliseconds. But trust me, there are a lot of problems and outliers hidden in that average. So use things like the minimum, the maximum, or the 95th percentile of a figure to identify the actual spread that is hidden in that average. Now, if you know me, you know that I am a big fan of nuancing everything I say. But in this case, it's really important to understand that I'm not saying to not monitor your systems. Of course, you need to monitor your systems, because if your system is down, trust me, there will be no happy user. And if your free disk space is gone from 10% to 2% in the last 24 hours, that's a great leading indicator that there are not going to be any happy users tomorrow. So there is definitely value there. And the same goes for averages. They can give you a very quick insight into they can give you a very good insight into how things are going roughly. But there are no silver bullets, either of them. And to give you a number of examples, I've worked for a couple of years at a company that had a lot of databases. And the usage of all those databases was somewhere between 20 and 30% on average, I think. This is a little bit lower. And we had one database that all of a sudden it spiked to 100%, it stayed there for a couple of minutes, and then it dropped down again. So one of our operators noticed that later on, and he said, we have a problem. I said, oh, what up? And he said, well, we have this database and it has been used for more than for 100% for a couple of minutes. So my first response, and this is actually really true, was, well, that's a great thing because now we're finally using what we're paying for. While acknowledging that that was true, the operator was not satisfied because his argument was that the user was not happy because the user wanted more performance out of the database than he or she was actually getting. Now, we had a bit of a back and forth, and I'm dramatizing now, by the way, but what we did in the end, we decided to call the customer because the customer can really tell us what was happening and if he was still satisfied. So we called the customer, and what happened actually was that he came into the office, 20 seconds before 8:30. He walked to his computer, turned it on, and started a very big report. And then he would walk away from his computer while that report was generating, get a coffee, talk to his colleagues, etc., and say to everybody, "No, sorry, can't work, waiting for the report." And then go back to his computer 5 minutes later on for the report to be ready. So I had this theory that if we gave that person, like, say, 5 times the database performance, it would cost us 5 times the money, but the user would be less satisfied. Because instead of getting a coffee, having a chill at the start of his day, that report will be done very quickly, and he would have gotten to work even sooner. So the proposed alert from our operators at 80% usage and an automatic scale up was not necessarily a good thing. The user didn't need it. Of course, he wouldn't complain, but he didn't really need it. We could use the money better somewhere else. Another example. Let's say I have a graph of the average response time of my API, and it's somewhere between 100 and 140 milliseconds. Are my users happy? I don't know. It's just a very, very standard average. So let's graph the maximum response time for that same API. Now, I don't know if all my users are happy, but I definitely know that some of my users are not happy. So response time well over half a second or even close to a second is way too long for most APIs. Or instead of using the maximum, I can apply another trick, and that's the trick of dimensions. So what I do is I take this one graph, which is in blue, and I split it into 2 graphs, one for each operation on my API. One for the view item, which is on the bottom, very, very quick. And the other one is for adding that item to my shopping basket on the top. So looking at an item is very quick, and then somebody wants to buy it, and that's rather slow. I might actually be losing revenue here. So maybe my users are not so happy here, even though the initial graph didn't really indicate that. So my tip here is to use percentiles. Now, I'm not going to do that. I'm not going to walk up and down my room, but percentiles can be a great tool here. And going back to not focusing on your system, really measure things that the user cares about and think it through, because it's not necessarily as easy as you think. And I have a very, very simple example of that. So here I have a dashboard that I created in the Azure portal, and we will see how to create one for ourselves later on. And this is from a message that has a web API. I hope we are still connected because I get a lot of noise. That gets a message, puts it on a service bus, and then there is another component picking up that message again. Now I want to monitor if my user is happy, if my system is delivering service and value. Now, if you get into this situation, a lot of people would start monitoring the number of messages on the queue. But that's not really a good metric. Because if my system is doing 1,000 messages per second and there are 25 on the queue, that's not a problem. But if there are 5 messages on the queue and my system is doing 1 every minute, that might be a problem. So instead of just graphing the number of messages on the queue, which you see here on the top left, and comparing those to the number of incoming messages on the queue and the number of outgoing messages on the queue, which are very overlapping, indicating that every message is being picked up almost instantaneously, it might be much, much more interesting to take a look at the delay between queuing the message and processing the message. And this is a thing that we cannot retrieve that from default metrics, but it's a thing that we can calculate in our application once we're done with the message, and then we can emit a metric ourselves in a way we just saw before. And as I say, averages can be lying, cheating bastards. If we now take a look at the maximum processing delay every minute, you can see that there are some very, very weird spikes in this system. And I know why, by the way, because somebody built in random delays. To give you another example of a dashboard that I created pretty recently, that's this one. And if you look very closely at this one, you will see that it talks about operations and actions, the number of actions that succeed, operations that succeed. And you can see that I have a thing called bogus.testcheck. So a lot of synthetic traffic going through the system. But the things that I graph here are not system metrics. They are actually things that the business are interested. So this dashboard is published not to the operators, but to the product owners and the chief product owners. And this is actually these are metrics that I'm gathering near real time in my system instead of spreadsheeting them afterwards out of databases. Now, a lot of the things that I've just told you, I've learned throughout the years by making a lot of mistakes, probably still saying some weird things now. But I came across a book, I think 2 years ago. It's called Practical Monitoring. It's written by Mike Julian, and it's a very good book that highlights a number of the things that I've been saying as well. So I can recommend it for those who don't like reading. It's also quite thin. Now, so this is the theory at the start. Now we've talked about what to monitor and what not to monitor. And now you might be wondering, okay, cool, I'm using Azure. How can I go about this? So in Azure, there used to be 3 service offerings that we could use for doing logging and instrumentation: Application Insights, Log Analytics, and the Azure Monitor. So Application Insights was focused on getting stuff using an SDK out of my own application and using an agent from the stack under it. Log Analytics was more focused on getting a lot of logs and metrics out of all kinds of other services in Azure virtual machines. I think load balancers can emit logs there. Things that the audit log for the Azure portal itself, they go into Log Analytics. And then we had another monitor, which started collecting metrics for all, so the numbers and the graphs for all the other services in Azure. Now, more recently, they have been unified and it's now all called Azure Monitor. So Azure Monitor is that place where your metrics and your logs are living within Azure. Now, a quick recap. What can we get for metrics out of Azure? So first of all, we can get what are called platform metrics. Every service in Azure generates a number of metrics that you can get out of that service for free. And it's actually recorded for 90 days. Sorry, I had to click one more time. It's retained for 90 days. I think actually 93. So they can always say more than 3 months. It's enabled by default and free. And which metrics are available differs from service to service and should always be the metrics that are interesting for you as a user of that specific service. So for a database, you can get the amount of IOPS, the amount of log IO. And for a storage account, you can get the number of block transactions or the kind of things. So it differs from service to service. The second thing that we can get using Application Insights are application metrics. And these are all the things about our application host and the stack below it. CPU percentage, response times, memory usage, number of requests per second. All the things that don't differ from application to application. So that my web API generates, but your web APIs as well. Now to use that, you have to install that NuGet package into your web API, configure the instrumentation key, and you're done. And then we have the third thing, which are the custom metrics. Again, using Application Insights, but these are the things that you emit yourself. And you've seen this at the start actually. We install the NuGet package, configure the instrumentation key, and then we use the telemetry client class to start emitting values. Logging, there are also a number of different things that get recorded. And please forgive me the graphics. So first of all, every single request is recorded. When it starts, when it completes, the status code, the URL, called the operation name, those kind of things. Now within the boundary of every request, which has an operation ID, all the log messages are being recorded. They are called traces, and every trace has the operation ID on it as well, so you can relate it back to the request. All the dependency calls that you make, for example, using HTTP client, but also into, I don't know, Service Bus, Cosmos DB, SQL DB. More log messages, all the exceptions that occur, and even more log message. And this for every request. Now, I have shown you at the start already how you can take an existing application and add logging and instrumentation to it. Now, what I now want to do is I want to almost do another demo with an application that I've prepared up front. And as everybody who does public speaking, I have created a URL shortener application. And its architecture looks something like this. I have an Azure function app that runs a number of functions. The first one is an HTTP trigger that I can post an alias to, so an alias and an actual URL. That function puts that message on the queue, and then I have a second function picking up that message and adding that queue actually to a Redis database, that alias to the Redis database. Then I have an HTTP trigger that I can use to query for a specific alias. This goes directly to the Redis database, and then I have an HTTP trigger that I can use to get the statistics for a sample alias. So it will return me the URL that it redirects to and how often it has been called using getAlias. Now I wanted to get to use this to generate some traffic to show some of the things of application insights. And since I am a lazy person, I generated an Azure function app next to it on the left that has a timer trigger. So every 2 seconds, it executes a load gen, which calls into add alias a number of times into get alias, and then into get statistics. And I have another timer trigger that runs every 4 hours, and it clears out the Redis database. And that's cool, because now I have a demo that resets itself every 4 hours and continues to generate data. Now, feeling guilty for being lazy, I added one more thing, which is a third function app. And that also responds to a queue. So whenever a new alias is added, it gets that message and it dumps that into a SQL database, which is kind of a warehouse with insights that are being gathered there, so to speak. And what it does, it puts that same message on another queue again, so that it gets called again an hour later. It gets the statistics for that specific alias and puts it into the SQL database as well. Now, this application I've written, and we'll take a look at that, and hopefully you will see the different parts of those architectures that we've talked about within that application as well. So going back to my other screen, this is actually the application that I wrote. So there are a number of projects. One with an ARM template, one with my main functions, which is the add alias processor, get alias, get statistics, the function app for the reporting functions, and the function app for the load generator. And I've separated all the logic out into a separate DLL out of habit. Now what I do here, first of all, in the startup, it's really interesting. I do not do, what is it called? Services.add application insights telemetry. I don't have to do that here because an ASP.NET Core application runs directly on a web service, but an Azure and has to instantiate application insights itself. A function app runs on top of the function's runtime. And the function runtime already has application insights classes registered by default. So I don't have to do that myself anymore. The only thing that I have to do is I have to add an instrumentation key, because otherwise data cannot be sent anywhere. Now another thing I do here is I add an implementation of an interface called iTelemetry initializer. What I can do in a telemetry initializer is whenever new telemetry comes in, I can manipulate it a little bit before it gets recorded. So what I'm doing here, whenever a new telemetry comes in, I check it for being null, and I check it for being of type request. And if it is a request, and it does not contain an author yet, I'm going to add an author, and then add my own name. Now what this does, it adds to every request a custom property called author, and then the value. The author property is not really valuable, but you can imagine that things like, I don't know, virtual machine name or anything else might be interesting for you. And you can also inject other things into this telemetry initializer, so you can make this context aware and start adding extra properties to all the things recorded by application insights, if you desire so. And from there on, I have my implementation, but just trust me, I'm using instances of ilogger of t again to emit lines. And I'm using instances of the telemetry client again to emit metrics. Now, before we move on how to use this, I want to quickly show one more thing that I forgot to mention earlier. If we have a logger, remember that I might be interested in also specifying the value of certain variables. Now I can do things like this. What we're used to as developers to make this string interpolation. So now I'm sending a message. Let's make a debug melding. The count and then the value of the variable count is inserted into the string here. But what I can also do is I can remove the string interpolation and send in a second parameter to the log debug call. And what this will do, it will actually record this message as my log message, and it will also record that there is a property count with a value of 1. And the names of these two do not necessarily have to correspond, so I can do this as well. And this property bag of key value pairs will be added to my trace entry, and I can use that later on as well. Now, enough about getting stuff into application insights and into the Azure Monitor. Let's take a look at the things that we can do within Azure itself. So, zooming back in, let's start with, I don't know, platform metrics. I can look up any service, let's say service bus, and now I can open my service bus namespace for this application. And as with any resource, you immediately see a number of graphs. These are coming from the Azure Monitor and they are showing platform metrics. Now I can click these graphs to start editing them. But there is another thing that I can do. I can go to metrics. And this will give me a canvas where I can start plotting my own graph out of any metric that I have access to. And to plot a line, I need to provide 4 things. A scope, which is a resource in Azure, a metric namespace, the name of a metric, and the aggregation that I want to use to plot it. So let's say that I want to do for my HB URL shortener namespace service bus standard metrics. There's always just one metric namespace for every service, except for one exception that we will see later on. And let's say I'm interested in the number of incoming messages. And here I have the graph. Let's say that I am also interested in the number of outgoing messages. And here I have the graph. Let's say that I want to filter this to a specific queue. I add a filter. I define for which property, for which value, and there we go. Now, graphing things like this all the time is not necessarily a fun activity. So maybe we want to group graphs like this into dashboards. So what I can do is I can click Pin to Dashboard. I can either pin it to my current dashboard or select another dashboard. And then I get a drop down, select a resource group, an existing dashboard, and it will be added there. Now let's not do that right now. And then I can go to dashboards and I can see the different dashboards that I created this way. And once you get a little bit the hang of this, you can create a dashboard like this in anything between 10 and 20 minutes. So that's how easy it is to create dashboards out of metrics. Now let's say I want to get notified whenever this average processing delay goes above, I don't know, 10 seconds. So what I just did, I went to the dashboard, clicked on any graph, and now I drilled down into that single graph. I can make changes from average. I can change it to max. And it says, hey, you have unsaved changes. Do you want to save them to the dashboard? Well, absolutely not. But what I do want to do is I want to create a new alert rule. Now I get guided to an experience where I can start creating alert rules. And alert rules are created by selecting a resource, which is what we do here, and then selecting a condition, which is a combination of a metric and a threshold, and an action group. And an action group is just a label for a number of actions that we want to be executed whenever the condition for that resource is met. Now, because I come from an existing graph, the resource is pre-filled. The condition is also kind of pre-filled, but not complete. So let's click that, make it complete, and say that I want to get notified on a static threshold whenever the maximum is greater than 10,000, because this is in milliseconds. You can actually see that the threshold is here. Wow, I can even drag it nowadays. It's amazing. I get notified whenever it's above 4100. Now I can say how often I want this alert to be evaluated. So let's evaluate it every 15 minutes, and let's evaluate it over the last 30 minutes. And there is a constraint that I have to evaluate it at least as frequently as the period that I'm evaluating it over. Now you see that I have a proper condition. I select an action group. I already have one. I can also create a new one on the fly. It's not very interesting. It's just a name and then a number of actions. And an action can be anything like calling an Azure function, calling a logic app, sending an SMS text message, etc., etc. This is how you create alerts within Azure. Now there is one more final thing that I want to show when it comes to application insights, because all these graphs come from the Azure Monitor, but all the data is of course stored in these databases that I mentioned at the start. Now Azure wouldn't be Azure if you wouldn't also be granted access to all these databases. Not the database for platform metrics, but definitely the databases for all your own log entries and for all the metrics that come out of your own applications. So what I can do, I can go to logs and I get a query experience, which is very similar, by the way, to the Azure Data Explorer for those who are familiar with it. And in that query experience, I get a number of tables, traces, requests, dependencies, exceptions, custom metrics, things that are very, very similar to what we saw at the start on the local application insights experience. And now I can just do things like give me all requests, order them by the timestamp, descending, and well, let's not do all of them, but oh wow, that's unexpected. Let's not do all of them, but you know, just 10,000. I execute a query and bam, there's your result. Well, actually, there have just been 23 items in the default filter of the last 24 hours. So let's up that a little bit and say I want to do, I want to specify it in my query. So I'm going to say order by where timestamp is larger than ago 2400 hours, 10 days. 2400 hours. Okay, never mind. We're not going to get more than 23 items. But you can imagine that I can do this for requests. I can also do this for exceptions. So now I take all my exceptions, order them by timestamp, descending, and I might be interested in ordering in that result. And there we go. And the one thing that I want to show is that maybe I want to get notified whenever an exception is being made, comes in, and I want to get alerted. One thing I can do is I can select a query and create an alert rule out of it. And I think we're out of time. Looking a little bit at our host.
Focus on time, well. But do you still want to have some final remarks, or are you finished?
I have 3 finishing remarks. Just wanted to check in with you.
Sure. Let's make them.
Awesome. Okay, so what I've shown you right now is dashboards, the query experiencing for all the things that we've seen at the start, and how to create alerts out of it. Now, I have a few closing remarks indeed that I want to show. Now, for real, we've already done it. One thing that I pointed out at the start is that we have this SDK in our application. And that we have always seen that it is application insights. And from application insights, we directly ship our code of our logs and our metrics to another system using HTTPS. Now, if you recall from the start, there were two things that we used logging for: auditing and tracing. And often you want to separate between the two of them. And you can do that by not directly connecting application insights to the iLogger of T interface, but putting something else in between. For example, nlog or Serilog. I think Serilog is winning. And now what I can do is I can configure nlog to send some of the log entries to application insights, but maybe others to a visualization engine like SEC, which is very, very simple and down to earth, or maybe store very detailed logs on the local file system that I can exfiltrate if the need arises. And then from there on, I can ship it off to other systems. And I can also separate between the tracing and the auditing stream. Now, two final things. All the alerts and all the graphs and all the dashboards that I've shown, you can create them in the portal, as I just showed. But they are actually resources in Azure. And just as for Azure, every resource in Azure, you can create them using infrastructure as code or ARM templates in specific. So I can just go into the portal, go to my dashboard, click download, and now I get a JSON file. I'm thoroughly ashamed that my default editor on this computer is WordPad, by the way. And I get a very large JSON file which describes this dashboard. And I can use this in an ARM template to recreate that same dashboard, for example, to a test and a production environment. And the second final conclusion, the second thing that I wanted to show is, actually I mixed them up, I see, is that all the demos that I've shown are also available on my GitHub account, which is github.com/henrybeen. And there you can download this continuously running demo that resets itself every 4 hours, so you can play with the things that I've shown. And that's all I wanted to say, except for encouraging you to try this at home, where you probably are already right now. And thank you for your attention. And Geert, thank you for the invitation. I'm happy to take any questions if there are any.
I don't see any questions currently in the chat. If anyone has some final questions, please post them now because there's a little bit of delay. First of all, thank you, Henry, for this awesome talk. Hopefully my microphone is working now. Do you still hear me normal? Or is
there is a lot of distortion, unfortunately, yes.
Okay. I don't know what happened.
Now it's fine. I think
okay.
If you talk a little bit out of the direction of the microphone, you're good.
So this is better?
Yes, there I fixed it.
Okay. Okay, I was having some weird stuff. My microphone was muted all the time, and then you were saying, "Hey, I hear some noise." I was like, "Oh, my microphone should be muted." So, anyways, thank you for this cool talk. Yeah, I already saw the talk. I think we met last time again in Finland, so that's where I had the idea. Oh, we want to have you on the show. So thanks for that. Hopefully we can meet again on real conference in the future again.
I hope so. Will be a while, probably.
Yeah, the first couple of them will be probably be online this year. I don't see that many real conferences happening this year, but you never know. So if you like this talk, please give it a thumbs up on YouTube, subscribe to this channel, and hopefully I'll see you at the next shows again. Yeah, Henry, well, thank you for being here, and to all the viewers, thanks for watching as well. And see you at the next show. We're planning on doing a panel discussion with a couple of people during Azure Global Azure Bootcamp. It's Global Azure now, I think, called. But that's still unclear, but that should be somewhere Friday, this Thursday or Friday or Saturday. But try to getting the right people online at the same time is hard. especially during these hard times. So when we have the date, we will post them on the YouTube channel and on socials. So talk to you later, everyone. Bye bye.